There are moments in automotive history that define what's truly possible, and then there are moments that redefine it entirely. What you're looking at right now is approximately $4 million of French engineering split in half. A Bugatti Chiron Pur Sport, one of the rarest, most technologically complex hypercars ever built by human hands. And it is in two pieces on a garage floor in Miami, the rear, the front, separated. Bugatti's engineers said this couldn't be done without their proprietary tooling. Their official response when asked for parts: they refused to sell them. Their official position on whether a private garage could perform this repair: you can't just do that in a garage. Matt heard that, and he got to work anyway. And if you've never seen this channel before, stop right now and hit that subscribe button, because this rebuild is one of the most insane things ever attempted in a private garage. And you do not want to miss a single second of what's coming. To understand why this rebuild matters, you need to understand what actually broke. At the heart of a Bugatti Chiron's rear architecture sits a critical aluminum casting, the engine and gearbox mounting bracket. It's not a decorative piece. It's not a secondary component you can work around. This single part physically anchors the entire powertrain to the chassis. The 8-liter W16 engine for turbochargers, 1,500 horsepower, hangs from it. The gearbox that routes all that power to the wheels connects through it. 3 crankshaft position sensors thread into it, feeding real-time data to the ECU so the engine knows exactly when to fire. When Alex crashed the Chiron, the front impact was violent enough to shift the powertrain forward, and that casting, that irreplaceable Bugatti exclusive casting, fractured. That's when Bugatti told Matt the car was finished. That's when Matt started looking for options. The way he saw it, there were 2 paths forward. Path 1, 3D scan the original casting, reverse engineer it, and CNC machine an entirely new one from a solid billet of aluminum. Theoretically cleaner, potentially stronger, but carrying a risk so significant it could end the entire project if the crank sensor positions deviate by even a fraction of a millimeter from the original. The engine won't start, or it'll run rough, or under boost, it'll misfire catastrophically. From scan to machine part, tolerances drift. And on a car this sensitive, drift is dangerous. Path 2, repair the original, cheaper, faster, preserves factory geometry. But there was one enormous unknown hanging over everything. Could it actually be welded? Aluminum alloys are not all created equal. Some weld beautifully. Some are brittle nightmares that crack the moment heat touches them. And some particularly high magnesium content alloys won't weld at all. When the team identified the material stamp on the casting, the engineer in the room went quiet for a moment. The word magnesium tends to do that to welders, but after analysis, after research, after conversations with metallurgists, the verdict came back. It was weldable, and that's when they took it to Bob. And before we get to Bob, seriously, if you're watching this and you haven't subscribed yet, do it now. This series is only getting bigger, and the algorithm will stop showing you these videos if you're not on the channel. One tap. You won't regret it. Bob isn't a Bugatti technician. He doesn't have factory certification. He doesn't have millions of pounds in proprietary equipment. What Bob has is decades of machining experience and an instinct for aluminum that most engineers spend careers trying to develop. Before he touches a welding torch to this part, he does something Bugatti probably didn't anticipate. He mills it. He puts the broken casting into his milling machine and precisely verifies every measurement, every datum point, every reference surface. He's not guessing. He's confirming that when the weld goes in, it goes in at exactly the geometry the factory intended. Then he tack welds it, just enough to hold alignment. Then he puts it in the oven. This is where the engineering becomes art. If you weld aluminum cold, the heat gradient across the part creates stress. The weld area expands and contracts at a different rate than the surrounding material. Over time, under load, that mismatch becomes a crack. So Bob brings the entire casting to a uniform temperature first. When the metal is consistent throughout, the weld integrates, not just bonds, but becomes part of the molecular structure of the surrounding material. He selects his filler rod, 4047 alloy, chosen for its flow characteristics, its ability to penetrate and fuse with the base material rather than sitting on top of it, and then he begins. Watch the weld pool. That's not just metal being joined. That's the moment this entire rebuild either lives or dies. It's flowing. No porosity, no inclusions, Clean, smooth, continuous speed. Bob pauses, evaluates. He's not done, because Bob isn't satisfied with simply repairing the crack. He looks at the original casting design at the places where the factory left open sections in the aluminum structure, necessary gaps in the casting process to prevent heat concentration during manufacture, and he sees an opportunity. He cuts cardboard templates, precise ones. He's designing internal reinforcement ribs to fill those original voids. Infill sections that will bond to the casting wall and distribute load across a wider surface area. Bugatti didn't do this from the factory. Casting design requires uniform wall thickness to manage heat flow during the molding process. You can't simply add ribs wherever you want without risking voids and cold shuts in the aluminum. But Bob isn't casting, he's fabricating. Different rules apply. When this is finished, the mounting won't just be repaired. It will be stronger than the day it left Bugatti's factory. The decision is made. They're using the repaired original, and the whole engine is about to hang from Bob's weld. If this moment gave you chills, drop a thumbs up right now. Every like tells the algorithm this story deserves to be seen. And if you want to follow every step of this rebuild as it happens, hit subscribe and turn on notifications. We are nowhere near done. Reconnecting a Bugatti powertrain isn't like fitting an engine into a conventional car. There's no simple engine bay with clear access. Everything on this machine is layered components nested inside components. Wiring looms threaded through spaces measured in millimeters. Cooling lines rooted in paths only a Bugatti engineer with a factory diagram fully understands. Matt and his team are doing this without those diagrams. What they have, photographs taken during disassembly. Years of mechanical intuition and a refusal to accept that it can't be done. First, the wastegates. Each of the four turbochargers feeds through an electronic wastegate that regulates boost pressure with surgical precision. These aren't passive mechanical valves, they're actuated by motors, reading signals from the ECU, opening and closing to protect the engine from overboosting under hard acceleration. Getting them seated correctly, connected, and sealed before the engine goes back in is non-negotiable. Leave one disconnected, and you're gambling with a 1500 horsepower engine running uncontrolled boost pressure. Matt gets them in, then the mounting bolts. Small titanium fasteners. 2 of them. They'll carry the entire weight of the engine and gearbox combination. They thread into the bracket that Bob rebuilt. This is the moment. Matt steps back. The crane takes the load. The engine settles and rests on Bob's weld. No creak, no shift, no drop. It holds right there. That moment. A repaired Bugatti engine mount welded in a machine shop by a man Bugatti's engineers have never heard of, holding up one of the most complex powertrains ever put in a road car. If that doesn't make you want to see what happens next, nothing will. Subscribe if you haven't already. This journey is just getting started. The flywheel goes in next, and it can only go in one way. There's a single dowel pin that indexes its rotational position because the crank sensors need to read that flywheel's teeth at a specific reference point. Install it rotated 180 degrees, and you've just told the ECU a lie about where the engine is in its firing cycle. The result would be a car that cranks but never starts, or worse, one that starts and immediately throws every sensor fault code in the system. Every bolt gets torqued in sequence. Loctite applied. Uniformity is the goal, and an even flywheel creates vibration that propagates through the entire drivetrain at engine speeds. Then comes the gearbox connection. The dual clutch gearbox on a Chiron Pur Sport is a masterpiece of packaging. It also has more external solenoids than most gearboxes have total components. Each solenoid controls a different gear selection function, and every one of them shares the same electrical connector format. There's numbering on the wiring loom. There's numbering on the solenoids. But one misconnection, and second gear might select fourth, or reverse, or nothing at all. They work slowly, deliberately, every plug confirmed before they move to the next. One interesting discovery along the way: the starter motor, the component responsible for spinning a 16-cylinder, 4-turbo engine, tow life stamped with a part number that traces directly back to a Volkswagen Passat 1.9 TDI diesel. Same part, identical number. The engineering philosophy of platform sharing across the Volkswagen Group taken to its most extreme, most surreal conclusion: one starter motor. 2 very different cars. If you're finding these details as wild as we do, the comment section is open. Drop a comment below telling us what you think is going to happen when Matt finally turns that key. And while you're down there, smash that like button. It genuinely helps this video reach more people who love this kind of build.